So let's get started. So my talk is about taking Hadoop to enterprise security standards, but it's a pretty wide topic. I'm not going to talk about everything. So I'm talking about more like access control, and yeah, let me get the cue. Is it working? Yeah. So it's mainly about access control, and it's not access control of services in Hadoop. It's access control of data in Hadoop. So just to get a statistics, how many people implement access control in Hadoop or need access control in Hadoop right now? I guess many. And for the rest, you should be thinking about it at least at the end of the presentation. So it's all about keeping the data secure. Thinking about it, why we need to keep data secure. The first reason is members give you data and they trust you to handle it properly. If you mishandle it, they won't give you data, and probably it will hurt your image. And second thing is, you must have seen all the major companies getting compromised, like Apple, Facebook, and a lot of companies getting compromised by Java exploit or even Flash exploit. And there are hackers that are very determined to get to the data in big companies. And it's getting more and more because people started to use a variety of devices to access the data, from Windows PC to Linux to mobiles and iPads. So there are a lot of area to cover for security people. And there's also a possibility of internal threat. For example, some employee published accidentally or even intentionally the data, and you wanted to protect against that. So when you think of it, if you have a more granular access control, more people can have access to the data. For example, let's say a software engineer or even a customer support comes to you and asks for Hadoop access, account to your Hadoop. If your Hadoop cluster is not secured enough, you think, oh, I have email data or I have phone numbers, oh, you don't need that and you shouldn't have access to Hadoop. So that's what your answer will be. But if you have a very good access control, you can give them what they need and not anything more. So actually here, security helps Hadoop democratize itself. So what's happening now? So first is you have a lot of execution engines over top of Hadoop. You have Peak, Hive, Storm, Cascading, you can write Java program. So with all these execution engines, it's difficult to do access control on each specific execution engine. Then you have to take care of the other one. It's this chase never ends. What if a new execution comes in and people wants to use it, and you can't say no just because it doesn't have access control. So then obviously, people can write custom code. It's not just, for example, in Hive, it's not just SQL is running. You can do a streaming job or other things. So just expecting SQL queries, it's not true. People can execute custom code even if it's a SQL engine. And next one is auditing. So currently, auditing Hadoop is not so great. Even for example, when you wanted to see who accessed this particular column, I wanted to know a list of people who access this particular column. You cannot get it today because Hadoop sees everything as a file access, and this list of users access this file, and you don't know what they did with that. And talking about HTTPS file permissions, first, they are very coarse. They are file level. So let's take this simple example. So let's say you have a table with a user ID, email address, IP address, and a billing address, some example table. So you have a security team that may be interested in user ID, email address, and IP address. So they don't want to do fraud analysis, fake account detection, those kind of things. And you have customer service professionals. They need access to user ID, email address, and billing address so that they can talk to the customers and see what can be done. And you can have a data scientist who need a user ID and an email address. So not email address, user ID and an IP address. So this is just with 3 groups. And in your enterprise, there may be like 10 groups or 20 groups. And there will be like one big table which has all the data in it. And it's very hard to do access control on that table. So either you have to do a copy of the table with different copies for different groups, or you have to do some magic around it. Even if you do some magic around it, there's another problem of how you change the group permissions or group membership. For example, someone comes and asks you, okay, I need to access this data. The request is valid, and you want to give the access to the data, but it will take like a couple of hours for the group permissions to propagate. And people like this introduces inefficiency. And there are some other solutions out there. Probably you have heard Apache Sentry. We looked at it. The problem with Apache Sentry is it works mainly with Hive and maybe Impala. And again, it executes everything in a kind of admin user. So if you have a UDF or a streaming job, it doesn't work. And it doesn't work with Java job or Pig or other jobs. So we run like a lot of variety of Hadoop jobs. So it's not an option. And there's some work going on at the Intel Rhino project. I talked to them, and they said they're more concentrated on HBase cell-level security. So again, it doesn't work with other jobs. So when you look at the challenges that we have, the first one is the mixed data. So before, you used to produce, okay, this is very secure data or secure table. So I can keep this table away from everyone. But that's not the case now. Security, the access control is not binary. It's not 0 or 1. It's very mixed. So you're in a particular data, like for example, like data coming from mobile, it will have IP address, it will have geolocation, it will have probably email address and phone number. There's like a lot of mixed data around it, and different people need different sets of this data. For example, some people doing location-based analysis probably need location data, and they don't need email data. So why would you give them email data? So there are a lot of mixed data going on. And you have multiple data processing systems. For example, we use Kafka, we use SAMSA, people use Strom, and other systems that may or may not coexist with Hadoop. So whatever the system you're coming with should be able to integrate into other systems. And lastly, like, the number of people using Hadoop has grown a lot. People who are non-technical started to use it. So product managers, customer support professionals. The one reason I can think of is because companies are going towards data-driven decisions. When people want to make a decision, they would need some data. And usually they go and ask to the data scientist, okay, give me this data. But things are changing, and they're trying to get the data themselves. So you are seeing a lot more increase in number of people using Hadoop. What that makes is it gives the attackers or hackers like a lot of targets. And these people are used like coming from Windows and all different variety of mobile phones. So it's pretty difficult to take care of all the diverse systems. So what do we need? First, we need an extensible authorization framework that should work across all the data pipeline. For example, it should work across Kafka, it should take care of Strom, or then it should work in Hadoop. It should be everywhere, and you should need just one place to control everything. You shouldn't go and do an access control on each of the systems. Then there will be inconsistency, and you can't make sure that everything will be in sync. And you need a fine-grained control. We have seen that the data can be mixed data, like all the PII information mixed with the public information. So you need a fine-grained control. And you need fast changes to these authorization rules. For example, someone will come and ask, okay, I need this data, can you give me the access? You should be able to give it, or else like you are reducing the efficiency of the user. So what's our solution? So this is our just a POC, and we are trying it out. So we thought, like, why can't we use encryption to do access control? And some people have already doing it. I know Square is doing it. So what we have is, like, we have this key server which can manage keys. So again, this is a big problem of managing keys that I'm not going to talk about this key management here. So whenever a web server, let's say like some front-end web server wants to produce an event, let's say a clickstream event. So the web server communicates with this key server, talking, okay, I'm the producer of this clickstream event. Give me the encryption keys for that. So the key server will give the web server a symmetric encryption key. We are using symmetric encryption here, and it will be like specific for that particular web server. So it's not like we are giving keys that are used in other producers. And the web server will know what fields to encrypt. So again, this can be either present in key server or can be present in the schema itself. We use Avro. So in Avro, you can tag specific fields with a particular labels. So we can say, okay, encrypt this particular column. So and the web server will encrypt those particular columns and sends to Kafka. Kafka is very schema agnostic or even format agnostic. It doesn't care about whether the fields are encrypted or not. So it works out of the box. And once, after the Kafka, it gets ETL to HDFS. Again, in HDFS, so far not problem. So once a particular job runs on top of HDFS, let's say you execute a Hive query or Peek or Java or cascading. So it will again communicate with the key server and gets the key for it. And the key server has the Active Directory connection. So we run a Kerberoist grid. So when the job talks to the key server, it kind of authenticates itself. And the key server will have active AD integration so that it knows, okay, what group this user belongs to, and it can get all the group information. Again, we are trying to use the Active Directory so that we don't have to reproduce the group hierarchy. So let's look in detail how a Hadoop job kind of encrypts stuff. So again, you have a key server with the AD integration. So let's say there's an ETL user trying to execute a job, and those gray lines are columns, unencrypted columns to start with. So the ETL user talks to the key server and gets the keys for, let's say, 3 columns. And these 3 columns are encrypted with the different keys. So access to those particular columns can be controlled separately and independently. And we are trying to use Parquet. Again, we pick it up columnar storage because we are doing column encryption. So columnar storage format is suitable. Let's say a particular user runs a job. So that user, again, talks to the key server. And that key server has access control list. For example, user A has access to only the 5th column. And the key server only gives the decryption keys only for that 5th column. So the rest of the columns, like column 2nd and column 4th, column 4 cannot be decrypted. And only the user A can decrypt column 5. Similarly, you have different users with a different level of access. Like a user C doesn't have any access to the encrypted columns. So I'll just get you into brief how it's get implemented in Parquet. So just brief overview of Parquet if you haven't already known. So Parquet is a columnar store. So it stores column-wise. So if you have a table, you have a row store there on the left and column store on the right. So it stores every column values together. So it achieves better compression, and your queries need not to read all the columns if it doesn't require all the columns. So the query, if you're executing a query on only a few columns, it reads only a few columns. Inside Parquet, you have row groups. These row groups are kind of a subset of the whole file. So inside a row group, all the rows are stored, like all the values for the rows are stored in a column-wise. And inside each column, we have a small division called pages. These pages are like anywhere from 64 KB to 1 MB. So how do we do encryption in Parquet? So we are trying to do like 3 kind of modes of encryption. The first mode is field mode, where we encrypt each field at a time. So we'll go over what are the use cases in the field mode next slide. And the second mode we do is like a page mode, where we encrypt the whole page. And in the hybrid mode, we do both. We do encrypt each field, and also we do a page mode, like a page level encryption too. So what's a field mode? So for example, let's say you have something like emails and stuff that people wants to use to join stuff, because that email is your primary key, and it may be email address, or it may be member ID, or it may be some other browser ID or something. And some people need to have full access to it, and some people just need that to join with other tables. So in that case, you can do a kind of a consistent encryption, where you can set the initialization vector to be constant or something, and you can give the access to that encrypted values to the users who just need them to join stuff. So for example, like if let's say this is some kind of activity table, and you have the email address. So when you see the second and third values are the same, so it maps to the same encrypted value. Again, this is not a kind of proper encryption. If you're doing proper encryption, it wouldn't happen. But we are intentionally doing it this way so that we can join stuff with the other dimension tables. So basically, how you do it in Parquet is take the n values that constitute a page and encrypt at each value at a time. So field mode, what it gives us? It gives us joins. You can do joins. You can do counts, count distincts, and you can do a distribution analysis. But you lose compression, almost no compression, which is the good advantage of column format. And also, it's an improper encryption, so people, if they are determined, they can do some cryptographic analysis and able to decipher some of the messages. But still, that's better than plain text. The next thing is the page mode, where we encrypt the whole page after compression. So you won't be getting any information except just the entropy of the data, like whether how many distinct values present. You can just estimate, because when you do compress, if your data is very repeated, so it compresses to a smaller page. And it's better for performance because you're doing encryption on a page level, so you don't have to call the encryption methods for each value. So the way it happens in Parquet is you take n values that constitute a page, then you do the encoding, which Parquet has many encodings, and you do compression, then you encrypt it. So people who see this page mode without the decryption keys, they don't get anything out of it, like there's no information leaked. So then the next one is the hybrid mode. So in hybrid mode, you get like a fine-grained control of information. For example, there are 2 keys involved in here. So the 2 encryption happens. You take n values, then you encrypt each value at a time, and also you do the encryption at the page level. So you have 2, and these 2 encryptions are with the 2 different keys. So you can either give 1 key to a particular user, or you can give 2 keys to the user. So to summarize that, when you see it, so you have this plain text value, then you have encrypted value, you have the just no access. These 3 kind of access that you can provide. The field mode provides the plain text access and the encrypted value, so you can choose between these 2 access. And the page mode provides the plain text access and no access. And hybrid mode does all 3. So again, we are limiting the exposure of the data and also making sure that the people can do their job. So if you have just like a binary kind of access, people will always ask for the most lenient way. Like they will come and ask, like, give me the plain text values. And it's very hard at scale to manage that, like to validate that request. So it's very hard for you to say, okay, you don't need a plain text access, because there's only two solutions exist when you do a page mode. You say, okay, you either get access or you either don't get access. But kind of hybrid mode gives you to do that a little bit granular. So you say, okay, you get access, but you cannot see the plain text value, but you can do some operations on top of it. So and also we'll be doing key versioning. So what is key versioning? So each key is versioned and it's specific to a particular source. And actually it's specific to a particular producer, because there will be a lot of producers for a particular event. For example, if it's a clickstream event, there will be a lot of web servers that produce that event. And these web servers have different keys among themselves, because a particular web server get compromised. You don't want that attacker to have access to all the events that are produced by other web servers. Again, it reduces the exposure when there's a leakage of keys. And you can do time-based access control. For example, like if you have newer version of key every day, then you can say by default, every data scientist in my company can have only access to last 30 days of data. And again, they can request for more days, but by default, that's access control. So you're not only doing like a column level and also table level. Also, you can doing time level access control, so that you can keep the historic data more secure. And again, like doing authentication of producers, since you're giving a different key for different producers, that authentication of producers can be done separately, not using this framework. And I talked about the key servers. So let's talk a little more about what are the key server features that we are getting. Because the key server is like a centralized server that's not only for Hadoop, but also for the web servers, for Kafka, and all other systems. So one thing you get is better auditing coverage. So as I said before, in Hadoop HDFS audit logs, when you say you get only the file-level access logs. So if a particular user access this particular file or not. So you need to know more than that. So this key server will exactly tell you, okay, this user accessed this column because that user requested the key for that column and I gave the keys, or I didn't give the keys. And with better auditing coverage, you can run a lot of anomaly detection here. So if you wanted to do, let's say, anomaly detection on top of this, let's say you look for people who suddenly started to access all the sensitive columns, you can do it here. It's just one place to do it. And also, you can put a multi-factor authentication on top of this. For example, if someone needs access to a particular data, they can get the data as long as they verify using multi-factor authentication. So either YubiKey or SMS or like a Google Authenticator. So it gives much more protection. And also, it increases the efficiency of the users. Like users don't have to wait for the administrator to go and give them access. And also, one more usage is you can do retention enforcement. For example, let's say, I think the European privacy laws are more stringent than other countries. So they say, okay, this IP address of the user can only be stored for the last 3 months. You cannot store more than that. So usually what people do is go and delete the IP address in the Hadoop or in other systems. But for sure, like what you can do is if the IP address is encrypted, then you can just delete those keys. Even if the data is out there, it's not usable. So you can do kind of a retention enforcement. So this is like a sample usage. So again, like we are trying to be as intrusive as possible. So the only thing you have to say when you're doing encryption is say what columns you have to encrypt. You basically say, okay, Parquet.encrypt, email, phone number. Okay, these are the columns that you have to encrypt. And the Parquet storer function will take care of the key manager, like getting the keys, encrypting it, and storing it. So you don't have to do it. And for reading, it's just simple. Like you just read it. Like there's no need to change any of your code. This is very important because in a big system company like us, like we have a lot of jobs, like incredibly lot number of jobs, so that if you need to modify your code, it's a big pain to go and modify each code to do tackle the encryption. So yeah, that's it. So if you have any questions, I can answer. Yeah, can you speak to the mic?
Somewhere earlier you said that even though, for example, me as a user don't have access to the exact email address, because the encrypted form stays stable, I can still do a join. But with the key rotation every day, that would mean that only the join within the day remains possible. Over days it won't be possible.
So for those things, key rotation is pretty difficult. Either you have to rotate the keys all at a time. For example, if all the tables which has the emails are ETL'd, in some cases it is every day. So then on that particular day you can do the key rotation. Again, if some user has stored a different table with that keys, it won't be useful. Yeah, for that, it's key rotation is a problem.
Hi. You said you use a key per column.
Yes.
And in your example with emails, you encrypt the email address and it is the same value. But is it still possible to join two tables? If there are different columns, I can imagine those columns have different keys.
Yeah, so the field mode, you have to be careful, or you have to set that setting in the key server. So for example, like if you have two tables, let's say you have your login table and you have your account table, both have emails. You have to give both keys. Keys should be the same.
Should be the same. Okay. So you can't prevent people seeing the email address in one table. And
that you can do it for the page mode. So if you're doing hybrid mode, so you have two keys. So one you're doing for the field mode and one you're doing it for page mode. You can still rotate the page mode and keep the key same for the field mode. Okay. So for an attacker who comes in, who doesn't have any access at all, still can't be able to access the data.
Okay, clear. Thank you.
Hi. Can you tell me how it affects the performance to encrypt?
So we ran couple of runs. We didn't see much degradation. Of course, there's some CPU needed for this. Again, like most of our jobs, most of data processing jobs we do is I/O bound. So the additional CPU doesn't make much difference. Okay. And the newer Intel CPUs, I think they come with the AES kind of a co-processor kind of thing, so they can do a much faster encryption decryption. I don't think we're using a library that utilizes that, but in future that's possible to do encryption and decryption using a hardware itself.
Okay, thank you.
So the encryption method which you use is actually deterministic. So if like two rows have the same value for a column, do they actually have the same encrypted value?
Yeah. So you can think of AES in ECB mode, like.
So that's very low.
Yeah, it's improper encryption, as I said. And again, like we are trying to limit the exposure. We can rather go with that, just giving a plain access. Plain text.
And about the page mode, do you add some salt or something?
Yes, the page mode is it's very secure. So you have the salt, the IV, and like everything like a normal encryption has.
Okay. Thank you.
So where do you store the salt for each page? Do you store it in the page, or do you store it somewhere else?
So I'm not sure about that. I think I was using our internal library, so I don't have an answer.
You have to store it somewhere.
Yeah, we should be able to. I think we are storing.
It's very secure.
Yeah, I think we are storing the page itself. think, yeah, last question.
How do you go about assigning particular keys to particular users in the key management?
So we have to have some kind of access control. So the keys are again is kind of a map to the table names or the event names. So basically, you say, okay, this event, these people have access to it, or since you're using Active Directory, so you say, okay, these groups of people have access to it. So you don't explicitly say this key belongs to this user, but the access control is at the table level or the column levels. Okay, I think I'm done here. Thank you, guys.